Motorcycles, at least mine, often don't have any indicator to tell you whether the battery is charging properly or not. If the battery isn't charging, or is charging poorly, there will come a time when you won't be able to start the bike anymore, and that's really inconvenient. On cars, there's a red battery warning light that comes on when there's a problem with the charging system. So the idea here isn't to add a warning light to my motorcycle, but something better. We're going to install a voltmeter that will let me monitor the battery voltage at all times, and we'll also see why it's not enough to simply connect it to a switched power source. Hi and welcome to Enjoy Wheels. So, the voltmeter is this one. It's an analog dashboard voltmeter for a car, but we're going to adapt it to install it on the motorcycle. I chose this model because I think it matches the bike's look. Just like my instrument cluster, it has a black background, white markings, a chrome bezel, and the same red backlighting. The idea is to install it roughly in this area, and since I couldn't find any adapter to mount a car gauge on motorcycle handlebars, we're going to have to make a 3D printed part. But first, let's test this analog voltmeter on the workbench. Here, my multimeter shows that this battery is at 12.3 volts. The wiring is very simple. The red wire goes to positive, and the blue wire goes to negative. The orange wire goes to positive for the backlight. Positive. Negative. And the needle moves. And I get about 12.3 volts. That's correct. I connect the backlight wire. Yes, it lights up. Now I'm going to increase the voltage by connecting a battery charger. I turn the charger on, and the voltage goes up. I'm now a little over 14 volts. What does my multimeter say? 14.2 volts, that matches. Alright, I disconnect the charger. Now what I want to know is how much current this analog voltmeter draws. So I connect my multimeter in ammeter mode, in series with the analog voltmeter. I select the low range since we're measuring a small current, less than 800 milliamps. I connect the COM terminal. Unset the selector to milliamps. And I read 58 milliamps. That's the consumption of the analog voltmeter with the backlight on. That's quite a lot, in my opinion. That's P equals U times I is equal to 12.3 times 0.058 equals 0.7 watts. So I disconnect the backlight. Maybe that's what's drawing power. I unplug the orange wire. The backlight turns off. The current drops, but it's still at 51 milliamps. So it's actually the needle movement that consumes most of the power. That means we can't connect this analog voltmeter directly to the motorcycle battery. It needs to be connected to a switched power source. Otherwise it will drain the battery quickly. The battery capacity is 14 amp hours, or 14,000 milliamp hours. The time to drain the battery is 14,000 divided by 58 milliamps, which is about 241 hours. That's roughly 10 days. That's not very long. After using the ammeter, make sure to unplug the LED, otherwise you might blow the multimeter fuse when switching back to voltage mode later. Now let's look at mounting the analog voltmeter on the motorcycle. First, I measure the handlebar diameter. It's 22 millimeters, and the hole required for the analog voltmeter is 52 millimeters in diameter. I want to mount it right here, so I'll need a system that allows adjustment, because the handlebar is at about a 45-degree angle. So I designed 3 parts using FreeCAD. Here is the lower handlebar clamp. Here is the upper clamp. And here is the gauge holder. There are slots here so the instrument can be adjusted, and once assembled, it looks like this. Of course, screws still need to be added. Here is the 3D printed gauge holder. I'll show you the other parts after painting. The back of the analog voltmeter is white, and I want it black. I could paint everything first and assemble later, but I'm not sure the paint will hold on the threads when tightening the ring. So I'll mount the analog voltmeter first, and then paint it. I don't want to paint over the label, so I remove it. Now I mask the areas that shouldn't be painted. I start with the connector. I don't mask this black part, we'll let the paint cover it. But I don't want any paint near the needle, so I fully mask that area. Before painting, I clean the surface with a degreaser. First the small part, then the larger one. I make sure to clean well where the label was. This removes any glue residue. I go all the way around. Now I let the product evaporate for a moment. I'll add a bit more masking to the holder. I don't want to paint this area. And I also mask around here. On this side, I leave the paper slightly lifted. On the other side, I press it down firmly. The paint I'm using is this one, matte black bumper paint for cars. What's nice is that it adheres directly to plastic, so no primer is needed. I shake it for 1 minute. And apply the first coat. Let it dry for about 10 minutes. After 10 to 15 minutes, the glossy finish turns matte. Then I can apply the second coat. Now I let the second coat dry. Once it's matte, I can remove the masking. For the small part, it's done. Ah, there's a spot missing some paint. I'll add a quick extra coat. I mask just this area. There we go, and let it dry again. Now I remove the masking again. There we go. Around the connector, you can see it's still white, but once installed, it won't be visible, just a little through here. The threads look a bit light from this angle. So I'm not going to leave it like that. I'll repaint while angling the spray like this. So I mask again. Repaint. And wait for it to dry. I remove the masking again. I'm really happy with the result. Now let me show you the other 3D printed parts. Here's the upper clamp. I'll screw it here. Then the lower clamp goes like this. The handlebar will go through here. So on the bike, I can adjust it like this, rotate it, and also adjust it like this. For those interested, I used SLS 3D printing in PA12. The result is very strong. Now let's install it on the motorcycle. Since the handlebar vibrates quite a bit, I apply thread locker to the screws so it won't come loose. I'll mount it in this position. That's solid. Here's how it looks from another angle. And now, it needs to be wired to the motorcycle. So the wire will start from here. It will follow these other wires, then run behind this black plastic piece. To do that, I need to remove the seat, slide the tank back, and remove the chrome part. To see a bit better, I slide the tank back a little more. So here, I had already made a modification a long time ago. The goal was to cut power to the instrument cluster when the bike is off, because otherwise, from the factory, the battery would drain in about 15 days. I remove the electrical tape. And here, I know I have a switched positive. So yes, I said at the beginning of the video that it's not enough to just find a switched positive. We'll come back to that later. Now I also need a ground wire. I see a black wire. I'll bet on that one. I carefully cut into the insulation without cutting the wire. My multimeter's black LED is connected to the battery negative. Here, my multimeter is in continuity test mode. It beeps if there's continuity, and I touch the conductor of the black wire, and there's no beep, so it's not a ground wire. So I put some electrical tape back around the insulation I removed. Now I'm on the battery negative side. This cable here is one I installed myself, so that's ground, so we'll tap into it. It's very close to the battery, which will matter a bit later. I remove the tape. I connect a black wire to it. I strip the wire. And I'm going to use a solder seal connector. We heat it, and it solders. Here's the connector. Ah, it won't fit. Okay, I need to remove a bit more tape here. Now I pass the wires into the connector and heat it with a heat gun. Be careful not to melt anything behind it. There you go, the solder ring has melted. Stop heating. I route this ground wire under the tank. Before securing the wire properly, I'll first connect it to the analog voltmeter to check that everything works. I plug in the harness that came with the analog voltmeter. I'm going to cut the harness here to add connectors. I start with the blue wire, which is ground. I run the ground wire through. I strip it. And I heat the solder seal connector. As soon as the solder ring melts, stop. The yellow wire in the harness is not used, so I put some heat shrink on the end. I strip and join the red and orange wires together, which are the positive and the backlight. I add a red wire to them. There we go, it's melted. Ah, the end of the yellow heat shrink doesn't stay in place. Oh well, we'll leave it like that. The red wire follows exactly the black wire. It has to, otherwise we won't be able to slide the sleeve over. Now I remove the existing connector and will install a new one. Before soldering everything, I'm going to test the analog voltmeter, so I temporarily wrap the red wire here, and we'll see if it works. I connect my multimeter to the battery. My multimeter is in voltmeter mode. My battery reads 12.45 volts at rest. I turn the ignition on. So the voltage on the multimeter drops. That's normal. There's a load. And here's what I notice. There's still a difference between the voltage measured by the multimeter and the one shown on the analog voltmeter. On the multimeter, it's about 12.1 volts, and on the analog voltmeter, it's below 12 volts. Earlier, on the workbench, we were reading roughly the same voltage. That's strange, right? And if I connect the positive lead of my multimeter near the handlebar, where the analog voltmeter is connected, then the multimeter reads about 11.9 volts. And now, both the multimeter and the analog voltmeter show the same value. That means the location where you connect the voltmeter actually matters. Here's an explanation with a simplified diagram. So here, I have my battery, and to keep things simple, we'll say its voltage is 12 volts. Then, through wires that have some length, the battery powers the motorcycle's components through the ignition switch, such as the engine control unit, or ECU, the instrument cluster, the lighting, and so on. And at this point, I can connect my analog voltmeter. Of course, with this diagram, the voltage read by the analog voltmeter is 12 volts, except that in reality, the wire is not perfect. It has a very small but non-zero resistance, so I add the wire resistance to the diagram, and as a value, we'll use 0.05 ohms. Of course, we have the same thing on the ground side. Now, we need to take into account the fact that the motorcycle's components draw current to operate. To simplify, I'll assume a current draw of 4.95 amps, and our analog voltmeter also draws current. Earlier on the workbench, we saw it was a bit over 50 milliamps. I'll use 50 milliamps for simplicity. So, applying Kirchhoff's current law, the current flowing through the wires, and therefore through the resistance, is 0.05 amps plus 4.95 amps, which equals 5 amps. Applying Ohm's law across the resistance, we get a voltage of 0.05 ohms times 5 amps, which is 0.25 volts. Obviously, the same voltage drop applies on the ground wire. As a result, applying Kirchhoff's voltage law, the value read by the analog voltmeter is 12 minus 0.25 minus 0.25, which equals 11.5 volts. So we end up reading an incorrect battery voltage. How can we read the correct value? Well, what happens if I extend the voltmeter wires to connect it as close as possible to the battery? The extended wires aren't perfect either, so they also have resistance. The difference is that the voltage drop in those wires is much smaller. Applying Ohm's law, we get 0.05 ohms times 0.05 amps, which equals 2.5 millivolts. And so, applying Kirchhoff's voltage law, the voltage displayed by the analog voltmeter is 12 volts minus 2.5 millivolts minus 2.5 millivolts, which equals 11.995 volts. volts, so there's an error of 5 millivolts, which isn't visible on the analog voltmeter needle. So by connecting the analog voltmeter as close as possible to the battery, we get an accurate voltage reading. Of course, we can't leave it like that, because the analog voltmeter would drain the battery in about 10 days. So we need to add a relay that powers the voltmeter only when the ignition is on. So I extend the red wire all the way to the battery. I don't need to deal with the ground wire since it's already connected close to the battery. I use a small solder seal connector. And there we go. Now, before installing the relay, I'm going to sleeve the wires to make it cleaner and better protected. Since this loom opens up, I can run the wires directly inside. I'll also recover this section here. There we go. This is what it looks like behind the analog voltmeter. I reinstall the parts that can go back in place. So here's the relay I'm going to add. It's a relay with a fuse. It originally comes with a 30 amp fuse, but I replaced it with a 2 amp fuse, the smallest I have. The analog voltmeter draws about 60 milliamps, so 2 amps is more than enough. There's a bit of space here where I can install it. I remove the battery cover. There we go, and the relay will be installed here, behind the battery. I move the battery slightly because I'll need access to the positive terminal. I'm going to extend all the relay wires. It'll be easier to connect. For the wiring, black is battery ground. White is switched positive. Red is battery positive taken directly from the terminal. And the blue wire goes to the analog voltmeter. I start with the ground wire. I already have one solder seal connector, so I add another one. I cut and strip the wire. Then I install the solder seal connector. A quick tip: to avoid melting anything behind, I place some aluminum foil behind the connector. That's it for the relay ground. Next, I handle the switched positive. I know I have one here. I didn't show it earlier, but it couldn't be connected directly to the analog voltmeter either. The voltage drop was too high. There we go. It's soldered. I stripped the 2 remaining relay wires. Now I'm going to connect directly to the battery positive terminal. I'll use this connector here. Yes, it's blue, but that's where I'll connect the red wire, and I'll crimp it with a crimping tool. I insert the red wire into the connector and crimp it. I check that it holds, looks good. And I connect it to the battery positive terminal. Now there's one wire left, the blue one, which goes to the positive of the analog voltmeter. It melts. That's good. Now, before putting everything into the loom, let's test it. I connect my multimeter to the battery in voltmeter mode and place it on the handlebar. 12.55 volts. The bike is off. I turn the ignition on. The voltage drops because there's a load. Now the multimeter reads 12.2 volts, and the needle is just slightly above 12. That's much better. I start the engine. "13 volts, 13 volts, 13.5 volts, 13.8 volts. Now it's charging. Here I'm just under 14, so that's good, it works. Now I'll sleeve the wires and put everything back together. There we go. And here's what it looks like in the dark. To wrap things up, here's a chart showing the stabilized battery voltage with the engine running. If the engine is running and the battery voltage is below 12.8 volts, then the battery is discharging. Your charging system has a problem. If the voltage is between 12.8 volts and 13.8 volts, then the battery is neither discharging nor charging. There is still an issue with the charging system. Finally, if the voltage is above 13.8 volts, while still staying below 15 volts, then everything is good. The battery is charging. Now I can permanently monitor whether my battery is charging or not. Keep in mind that if the motorcycle still won't start after the battery has been fully charged, then the battery itself probably needs to be replaced. This video is now over. I hope you enjoyed it. If you did, feel free to share it, give it a thumbs up, leave a comment, or subscribe to the channel. See you soon on Enjoy Wheels.